Hello everyone, today I'll be showcasing an AI that will use supervised learning in order to predict whether or not a customer online shopping is going to go on with the purchase given this dataset. This dataset has about 17 different parameters and our label, which based on those parameters whether or not the customer did actually go on with their purchase. And then we're going to divide this data set into a training set and a testing set and see how many of those we can predict correctly. We're going to be specifically using the nearest neighbor algorithm, not even the k nearest one, the other variation. It's the original nearest neighbor algorithm, and we're not going to use any k-fold cross validation or anything of that. We're just going to split them into two. So let's actually jump into that. And on my terminal here I'm going to run it. So I'm going to run shopping.py, passing in the shopping.csv, which is this CSV file containing all of the data set, and let the system handle it. So it actually runs quite fast, but my system is a bit slow, so it takes a while for it to start running up. But yeah. So yep, here we have it. So we're going to calculate first off how many we got correct and how many we got false, and we'll see that we got pretty good chunk of them correctly. And then we're calculating the true positive rate and the true negative rate. So this accounts for sensitivity and specificity, where true positive rate is how many labels that how many customers did go on with the purchase, and then did we protect them correctly or not. So again, of those customers who completed the purchase, what's the percentage of our correct guesses or predictions there, and the true negative rate of the customers who did not go on with the purchase, how many of those did we predict correctly. And we'll see that for this iteration, and we can actually run it one more time. So we'll see for this iteration that we did predict about 40% true positive rate, but a whopping 90, almost 91% true negative rate. And if this runs again, we'll actually see that we can get pretty different true positive rate and true negative rate depending, and we can actually test it a couple of times. And if we implement something like the k-fold cross validation, we can actually improve our results or outputs, or we can test any of those other things. And yeah, we'll see here we got a bit different. So I think our performance here, our predictions is slightly worse, but not that noticeable, even with the true positive rate and the true negative rate. But we'll see that we can pretty consistently, almost accurately predict the true negative rates, but with about 40%, a little bit lower than 40%, we can have a true positive rate. Yeah, that's all for today's video. Thank you so much for watching, and have a nice day.